Welcome to this session on DCMA 14 point schedule assessment. Before we start, I want to remind you about the golden rules of project scheduling video we made earlier. If you have seen that video, you already know some important points about making a good schedule, like keeping logic correct, avoiding long durations, and using proper dependencies. Now, in this video, we are going to look at the DCMA 14 point schedule assessment, and you will notice that some of the points are similar to the rules we discussed earlier. But DCMA goes even further. Okay, it gives a checklist to make your schedule fully reliable, realistic, and credible. Okay, so here we have the introduction. You can see here DCMA was developed by the Defense Contracted Management Agency and industry standards for the schedule quality check ensures schedules are logical, reliable, and realistic, and used in Primavera P6 MS project and equipment reviews. So, the DCMA 14 point check was developed by the Defense Contract Management Agency as a structured method to evaluate the quality, reliability, and realism of project schedules. And it has now become an industry standards used in government and private project worldwide. Whether you are working in Primavera P6 or in a mesh project. So these checkpoints helps to ensure that a schedule is not just a list of activities, but a credible project management tool. Okay, so in this presentation, we will walk through each of the 14 checkpoints, including logic, leads, and lag, constraint, float, resources, and performance metrics like CPLI and BEI. Okay, so if you are following along, you will see that the few points in the DCMA overlap with the scheduling rules. Okay, so but there are also additional checkpoints that you must know to make your schedule professional and defendable. Okay, so by the end of this video, you will clearly understand how these checkpoints strengthen schedule quality and why they are so critical for delay analysis, EOT claims, and forensic schedule assessments. Okay, so check number one, we have here the logic. Okay, so here you can see we have ensured every activity has at least one predecessor and one successor. Okay, so missing links create gaps in schedule flow. Then threshold, you can see we should not it should not increase more than 5% without logic. Okay, so it's mean that every activity should have the predecessor and successor, but except the start milestone and the finish milestone. Okay, because the start milestone, should not have the predecessor, and the finish milestone definitely cannot have the successor. So we will skip the start milestone, then finish milestones. Okay, so every activity in a project should be connected. Each task must have at least one predecessor and one successor. If not, so we get gap and broken flows in the schedule. So the DCMS is not more than 5% of activities should be missing logic. So always make sure your tasks are linked properly. Okay. Next, we have check number two. You can see here we have here the leads. So leads actually we use it also called lag negative and leads. So leads we use for overlapping activities. Okay, you can see here we have here a very simple example. You can see here obtain building permits and submit the preliminary shop drawing. So actually, the relationship you can understand that we have finished to start. So and again, we have overlapped these two tasks with the minus 5 days. Okay, you can see here. So you can read here. No elective lag lead time allowed. You can see here the leads distort activity logic and risk modeling. Then threshold we have 0%. Okay, so now leads or lag negative lag are not allowed. Why? Because they distort the flow of activities and make risk analysis unreliable. For example, starting a task before the previous one is finished can hide real delays. So the threshold here we have 0. So simply avoid them. Okay. So after that, we have here check number 3, lags. Lags we use for gaps between two activities. Okay, you can see here I have just added a one example here. I have entered here 50 days lag just to show you. Actually, just in a picture, I have added here over the 50 days lag. And now you can see here in this bottom, I have just added a one example task to cover this gap. Okay, so according to DCMA, check point three, lags avoid the excessive positive lag between the activities and then replaced with the explicit activities where possible. Okay, so threshold you can see we have up to 5%. You can say so. Um, so we should not enter the long legs. Okay, if you will need, so you should enter here proper task. Okay, like we use this lag for waiting time, for curing time. So we should mention here proper inactivity and we should link them. Okay, like this you can see here. So using too much positive lag in is also a problem. For example, if you say task B will start 10 days after task A finish, so that create a lag. Instead, it's better to add a clear activity in between. DCMA says keep these cases to less than 5%. Okay, so we have here you can say threshold. Less than 5%. Okay, equal or less than 5%. Okay, so next we have check number 4, relationship types. So here you can see we have here the finish to start. So use finish to start as a default. So limit ss ff then sf usage. So threshold we have here up to 10%, you can say. So it's mean we should use FS relationship, more about 90%. Okay, so up to 10% we have for the other types of relationship. You can see as far as FF and SF. So the most reliable relationship is finish to start. So that means one task finish before the next start. So of course, sometimes you need start to start or finish to finish, but keep them limited. Not more than 10% of relationships should be these types. Okay, so next check number 5, we have hard constraints. Okay, so hard constraints, you can see minimize use of the hard constraints must finish on. And let me show you the right side picture. Here you can see we have here the schedule in MS project. Whenever we will assign a constraint on any activity, we will have here like the calendar symbol, okay, with that specific activity. And on the left side we have here the schedule in Primavera P6. You can see here whenever we will assign a constraint on any task, so you will have here the symbol of star, okay. So I hope this is clear. And we have threshold, you can say up to 5%. We can use constraints, okay. But hard constraints like the must finish on can lock the or lock the schedule in place and stop it from following the predecessor or naturally schedule. So we should use a softer or soft constraints like the start on earlier than like that. So hard constraint should be a limit to the you can say up to 5% or less. Okay. Next we have check number 6, high float. So here you can see activities with high float. So it should be less than 44 working days. High float may be signal open-ended or for logic, and we have threshold up to 5%. So I have here example. You can see in this schedule we have under the total float column. You can see we have here the float 286. So it is too much. Okay, so I have just showed you the example to make it understandable for everyone, so you can see here. So we should not have high float more than 44 days. Okay, so actually, if an activity has very high float, more than 44 working days, so it usually means there is a logic problem or an open-ended activity we have. So high float activities should be less than 5%. Okay, so I have mentioned here the threshold that we should not it should not increase uh, more than 5%. Okay, so I hope this is clear. So after that we have here the negative float. So I have added here the example, you can say with the -6 days. So we have here the negative float. So no activity should have negative float. It indicates logic conflicts or missed deadlines. Okay, so threshold we have here 0. So negative float means your schedule is already late compared to deadlines or logic. So it is a red flag. So the threshold is 0. So there should be no negative float. Okay. So this is actually very important point. Okay. All the points are very important. Okay. So after that we have check number 8. So high duration. You can see activities with the duration less than 44 working days. So break them activities with the duration, more than 24 working days. So break them into the smaller manageable tasks. So threshold we have up to 5%. Okay. So it's mean that the task which will increase the duration more than 44 days. So we should break into more activities. So I have added here two examples. Activity B, you can see we have 55 days, then activity F have 45 days. So that is the um, that is the problem according to DCMA point. Okay, so if any activity is longer than 44 working days, so it's too big. Break it into smaller, more manageable pieces. So this makes tracking easier. Again, we can say only 5% or less should fall into this category. Okay, so I hope this point is clear. Next, we have check number 9: invalidates, no actuals in the future, no forecast in the past. So we have threshold 0. Okay, So actually, this check is simple. Don't put actuals in the future, and do not put the forecast in the past. So it makes the schedule unrealistic. Threshold we have here is zero. Okay. So after that, we have check number 10. You can see here the resources. Okay. Activities must have proper resources assignment. You can see here I have assigned all the resources on all the tasks. And here you can see I have just highlighted two tasks that we don't have the resources on these activities. Okay, so missing resources you can see will be the unreliable cost or schedule. So it's very important. Okay, so threshold you can see we have up to 5%. So every activity should have the right resources assigned, whether labor, equipment, or cost. If resources are missing, so your cost and schedule plan cannot be trusted. So DCMA allows only 5% or less without resources task. Okay, so I hope this point is also clear. So after that, we have check number 11, missed task. So task in the progress but behind schedule. Too many means the unrealistic plan. So threshold we have up to 5%. So here we have the example here. You can see plumbing installation, electrical, rogging, then steel erection, then concrete slab pouring. So here you can see we have the green is the planned progress and the red is the actual. You can see the green bars planned completion 100%, then red bars actual progress lagging behind. Okay, so missed task you can see. So the task in progress but behind schedule. Okay, actually, these are tasks that are in progress but already behind schedule. So having too many of these means your plan is not realistic. So try to keep them within 5%. Okay, you have threshold 5%. Next, we have check number 12, critical path test. So, actually, this is important. You can see here, ensure CP has no broken or missing logic. So, critical CP is the actually CP means the critical path. Okay, CP must follow the continuously from start to finish, then threshold must pass. Okay, so this is important. You can see here we should have a proper critical path. Here you can see we have, I have just added a very simple example here. The critical path was continue up to here, up to roof slab, but after that you can see we have the non-critical. Again, we have the critical task. So according to DCMA, this is actually, not good for your schedule. Okay, so the schedule must have a valid critical path. So actually, this is not a valid critical path. Okay, so uh, you can say it's mean that it should clearly show which sequence of tasks drives the project completion. So without this, you cannot forecast the project finish date properly. So if you will see this type of critical task in your schedule, so you must check your schedule. Okay. Okay, so in check number 13, CPLI, critical path length index. Okay, so here you can see Myers the realism of the remaining duration. Then formula we have here, remaining duration plus total flow divided by remaining duration. So this is a formula that measures of your remaining schedule is realistic. It's a calculated as remaining duration. Here you can read here remaining duration plus total flow, then divided by the remaining duration. So The result must be 1.0 or higher. So anything below means your critical path is too optimistic. Okay. So I hope it is clear. Then check number 14, BEI, Baseline Execution Index. Here you can see we have here the formula for the BEI, number of the completed tasks divided by number of the baseline tasks to date. Okay, so here you can see it measures the execution versus baseline plan. Then formula is already I have read over there on the top. Okay, so BEI compares how many tasks were planned to be finished versus how many actually got finished. Okay, so if BEI is above 0.9, so you are on track. If it's below, so it's mean execution is falling behind the plan. Okay, so this is important. Okay. Okay, so here we have the summary of the DCMA check. 14 checks improve schedule quality, credibility, and reliability. So key areas, logics, constraints, float, execution, resources, etc. Widely applied in Primavera P6, MS Project, and Command Force. So essential for delay analysis, EOT, extension of time, claims, and schedule forensics. Okay, so to summarize the DCMA 14 point assessment, is like a health check for schedule. It improves the quality, it builds the credibility, and ensures that product forecasts are reliable. So these checks focus on logic, constraints, flow, resources, and execution, etc. So they are widely used in Primavera PCs and MS products, and they are essential when preparing for EOT claims or forensic schedule analysis. Okay, so if you apply these checks regularly, you can avoid, the weak schedules and manage your projects with the more confidence. Okay, so and before we close, I knew some of you may prefer reading instead of just watching slides, so that's why I have also prepared the full DCMA points assessment in a PDF file. So let me show you. So here you can see we have the PDF file as well. Okay. So if the slides were not fully clear, so you can read the details from this PDF, okay, and understand everything step by step with examples. You can see here. So we have complete 14 assessment points in this PDF file as well. Okay, you can see here. Okay, so I hope everything is clear related to the DCMA 14 assessment points. Actually, it's very important and we use for the schedule health report. Now let's move to the Primavera P6, and we have a path tools, and you can see schedule check report. Same things we have here. Use the schedule parameter form. You can see here the here we have a project name, logic, activities missing predecessor or successor. You can see negative legs, positive leg, long leg, relationship types, hard constants. No. So one thing more, you can see here the long legs relationship with the lag duration greater than. You can see 352 actually in a system we can see we have a h, so mean 352 hours. So let me convert into days. Let me use the calculator. Before you can see, let me calculate 352 divided by 8, so it should be 44. Okay, so you can see 44 Okay, so again here should be 44, again here should be 44. So actually here we have hours, so that's why 352, 352, 352. So next please, click on schedule check. On message, click on OK. So you can see check schedule report we have here. Okay, so here we have a project name. You can see here we have a logic, activities, missing predecessors and successors. So according to DCMA, it should be less than 5%, but we have 3.57%, means less than 5%. Okay. Next, we have a lag or a negative lag relationship with the long lag duration of less than 0%, zero. So, okay, less than 1%, zero. We have zero. Okay, next, please. You can see positive lag. It should be less than 5%, but we have zero. Next, we have long lags. You can see it should be relationship with the lag duration greater than 352 hours, means 44. Okay, so and it should be 5% of total schedule. Okay, less than 5%. So next you can see relationship types. The majority of relationship should be finished to start, and you can see here we have a it should be greater than 90%. So we have 88.41%. So it's mean we have uh, less than 90%. So that's why uh, system show us has highlighted in a red color. So red color is critical. So you can see it's mean we have here you can see we have here issue. Okay, so that's why system highlighted in with the red color. Okay, hard constraints that prevent the activities being removed. Okay, you can see. So here you can see the resources over oblique cost activities that do not have an expenses or the resources assigned. So we have 100%. Okay, so because we didn't define and assign resources on activities, so that's why. Okay, so activities missing predecessors or successors. So you can see here next system show us the complete detail. Okay, one by one logic, the missing activities we have to project work start and project completion. Okay, so next we have you can see the negative lag. Okay, there is no negative lag. Positive, there is no positive lag. Long lag, there is no long lag. Relationship types, you can see count 61. um, FS we have 88.41. FF mean F finish to finish we have 5.80%, and SS we have 5.80%. Okay, so next you can see FF finish to finish, start to start, start to start, start to start, start to start. So here we have the detail of activities for the finish to finish and start to start. So in short, actually, we have here the DCMA 14 assessment point, or you can say schedule checkpoint. In Primavera P6, you can generate this report. You can analyze your project schedule according to the DCMA 14 assessment point. Okay, so it's very interesting. Okay, okay. I hope everything is clear related to DCMA, and thank you so much for watching this video. See you in the next video.